All right, let's find the area of this regular triangle using the regular polygon formula. This is obviously an equilateral, equiangular triangle. I just want to practice using the regular polygon formula on something that we should be pretty good at by now. So let's say they give me in this question that the radius of this equilateral triangle is 8. So the radius is 8. Okay, so I need to drop a perpendicular from the center, creating a right triangle. So we have the radius, we have the apothem, we have the side of the triangle. Each angle of this equilateral triangle is 60 degrees. The radius bisects, creating a 30, 60, 90. Here's 30. 8's the hypotenuse. So we have the short side being 4. In this case, it's the apothem. The apothem is 4. And short side, long side, so the long side is going to be 4 radical 3. And truthfully, both sides are 4 radical 3 if you need to find the perimeter. Area is 1/2 AP. Oh, I guess we do need to find the perimeter. 1/2 AP. So we have 1/2 times 4. The length of one side is 8 radical 3. So in this case, the perimeter is going to be 24 radical 3. There's 3 sides to that perimeter. Half of 4 is 2. 2 times 24 is 48. So the area is 48 radical 3. Now remember, we also know that for a equilateral triangle, we could do s over 2 squared radical 3. Let's just compare this. So if s is 8 radical 3, then we can plug it in. 8 radical 3 over 2 quantity squared radical 3. 8 over 2 is 4. 4 radical 3 squared. Well, 4 squared is 16. Radical 3 squared is 3. 16 times 3 is 48. We didn't do anything to the radical 3, so we're in the same place. All right, so we have, remember, we have a radius of 8, and we found the apothem is 4. Okay, one that's very similar, and you need to really go carefully, is the hexagon. This is a regular hexagon. Once again, I have a radius of 8. Radius of 8, I want to find the area. Radius of 8. Each angle of the regular hexagon is 120 degrees. 120, 120, 120. Radius bisects it. Just like last time, I want to drop an altitude. For regular polygons, we're going to call that the apothem. And in this case, the short side is actually half of the length of the entire side of the hexagon. So if the radius is 8, that short side is 4, the other side is 4. So we know that s is equal to 8. Yes, it's no coincidence that the side and the radius of a hexagon will always be equal. That is always true. All right, so we have a long side of 4 radical 3. Long side is short side times radical 3. So A is equal to 1/2 AP, 1/2 of 4 radical 3. If one side is 8, the perimeter is 48. Half of 4 is 2. 2 times 48 is 96. So the area is 96 radical 3. Not a very good looking 6 there. 96 radical 3. No units. Not worried about the units. All right. And then, last one I want to look at is the pentagon. I have a regular pentagon. Once again, the radius is 8. There's the radius. From the center to one of the vertices. And once again, I want to drop in altitude. So first of all, we need to find out what each angle of a regular pentagon is. Now, you might remember or you might know that it's 108. If you don't, then you need to find the interior angle sum by doing n minus 2 times 180 degrees. In this case, n is 5. N stands for number of sides. 5 minus 2 is 3. 3 times 180 is 540. And to find one of the angles, I need to take 540 and divide it by 5. And that's 108. We know that the radius bisects the angle. So this angle is 54. 54 degrees. I need to find both A and X. And to do that, I'm going to use trig. So let me do X first. So X is the adjacent side. 8 is the hypotenuse. So that's going to be cosine of 54 degrees. And that equals X over 8. And the cosine of 54 is 0.5877. If you didn't get that, make sure your calculator is in degrees. That is a very sad situation if that doesn't happen. Multiply both sides by 8, and I get about 4.7. So if X is 4.7, then the length of one of the sides is 9.4. 9.4. So therefore, the perimeter is going to be 9.4 times 5, or 47.02. If you did 47, I'm okay with that. These are all approximations. All right, in order for us to use the formula 1/2 AP, I need to find A. I need to find A. So, still going to use 54. A is adjacent from, I'm sorry, A is, I got confused by the A. A is opposite of 54. A is opposite of 54. And 8 is the hypotenuse. And I've recommended in the past that you write these out so you don't get confused like I just did. So we have the sine of 54 degrees is equal to A over 8. In this case, A does not stand for adjacent. It stands for apothem. So we have to look up or punch into our calculator sine of 54, and we get 0.8090. Multiply both sides by 8, and you get 6.47. All right, now we're ready. So we know that A is equal to 6.47. The perimeter is 47.02. So we're going to go 6.47 times 47.02 divided by 2, and we're going to get 152.1 for our approximate area of that regular pentagon.